In this lesson, we'll introduce the concept of deep time. What is deep time? Well, deep time refers to really long periods of time. So long that they are really hard to intuitively grasp. We're talking about periods of time on the order of millions to tens of millions, hundreds of millions to billions of years. Now, why is deep time important? Because in the mid-1800s, the British naturalist Charles Darwin shocked the scientific world with the publication of The Origin of Species by Means of Natural Selection. Darwin was rejecting Christian ideas at the time about the origin of species and proposing a natural process that would account for the evolution and multiplication of species on Earth. Now, he argued that species multiplied over time, but critically, such a process required long periods of time, and if the Earth was young, then an evolutionary process would not fit so well with the observed diversity of species on the planet. So for evolution to explain life on Earth, the Earth must be very old. Well, fortunately for scientists, the rocks on Earth are clues to the past and record the passage of time. In fact, one of Darwin's arguments for species change was the fossil record, and we will call that line of evidence Exhibit A. Now, in Darwin's time, fossils were known about. So fossils indicated that many species that once existed were now extinct. So, for example, here we have a T-Rex, and it was clear that these organisms did not live on the planet in the 1800s. So they lived in the past. Now, what this means then is that fossils were a snapshot of the past, and the inference was, therefore, that life on Earth had changed. At one time, dinosaurs roamed the Earth, and today they don't. Things have changed. Now, Darwin had a great interest in geology. On his 5-year journey, he made many observations of geological formations. And one of those in South America are the Andes mountain range that run the length of South America. In fact, in the Andes then, Darwin had occasion to get off his ship and climb up some of the foothills in the mountains in the Andes mountain range. And indeed, he discovered some interesting things. High atop the Andes, he found fossilized shellfish. These would be like mussels and clams and so on. So here we have sea creatures at high elevations. Now, others had made similar discoveries, so this Darwin wasn't the first, but it did cry out for an explanation. What were these shellfish doing at such high elevations? Darwin concluded that the ancient seafloor where these creatures lived must have been raised up to the current height by geological processes like earthquakes and an uplifting of the land. Now, how long would it take to elevate a mountain? Well, Darwin got a hint after the 1835 earthquake off the coast of Chile. Here's the coast of Chile, the town of Concepcion here, and off the coast of Concepcion a large earthquake occurred, and it devastated the city of Concepcion, and Darwin got a first-hand look at the devastation. But people alerted him of something of interest out on the island of Santa Maria here, off the coast of Chile. Here's Santa Maria, and you can see it has some cliffs here where shellfish live. They attach themselves to the rocks in the intertidal zones here. Well, prior to the earthquake, shellfish live at sea level, and sometimes they're submerged by the high tide. But after the 1835 earthquake, those organisms were 8 feet above the high tide level. In other words, the earthquake apparently lifted the island of Santa Maria 8 feet vertically. Now, how long would it take to raise the land to the elevation of a mountain, like 16,000 feet? So how long would it take to sort of create the Andes mountain ranges? Well, given the 8-foot elevation per earthquake, it would take 2,000 earthquakes to reach an elevation of 16,000 feet. And if we assume that you get these big earthquakes once every 1,000 years or so, then it would take 2 million years to build the mountain. And 2 million years is much older than many Christians believe the earth according to biblical accounts. In fact, since that 1835 earthquake, the island of Santa Maria apparently had subsided. It decreased. It kind of sank back into the ocean. But in 2010, there was another large earthquake, and again, the island was raised up by that earthquake. And here we see the line of dying shellfish that have been elevated by the 2010 earthquake. We now know that what's going on, we have these plates, these tectonic plates that are slamming into each other, and one can go below the other, and that can create tremendous forces and pressures and push the land up and build mountains, and you get volcanoes and such. So we're talking about geological processes that are shaping mountain ranges in this case. And so the Andes have a history. They were elevated, scientists estimate, somewhere over the last 45 million years. And so it's this kind of observation of shellfish on the rocks and looking at the effects of earthquakes that led Darwin to surmise that the Earth was very old. Now, Darwin's acceptance of the extreme age of the Earth influenced his thinking about the fossils he found in South America. For instance, consider this organism called Glyptodon. It's a large mammal, and it was found in Argentina, and it's extinct. It has these bony plates for a shell. Now, Darwin was intrigued by this bony shell because he saw such a feature on another species, the modern armadillo. So the two have the similar kind of bony plate for armor. Now, otherwise, there's obvious size difference here. So it raised the question, are these two species related? Could it be that Glyptodon was an extinct ancestor to the modern armadillo? If so, there was clearly change over time. But if the Earth was old enough, then a series of small changes to Glyptodon over vast amounts of time might indeed be able to cause the reduction in size until we get to the size of the modern armadillo. So Darwin began to see that the currently existing species had a relationship to extinct species. Sometimes the extinct species went extinct, as in the case of dinosaurs. But other extinct organisms might be the ancestors of modern organisms. And so Darwin began to see then these extinct species as pictures, as snapshots of the past, and that modern species have a history that sometimes we get lucky and we uncover when we dig up fossilized creatures. So Darwin comes to believe then that the Earth is very old, and this is important because just as mountains can rise by small increments over vast amounts of time, so too small changes to living things over vast amounts of time might radically transform species and perhaps multiply species as well.